Turkey's high-altitude, long-endurance, unmanned combat aircraft, the Bayraktar AKINCI, has achieved another significant milestone with the successful testing of its latest Tolen precision-guided munition. This test highlights the continued evolution of Turkey's indigenous defense ecosystem, demonstrating not only the increasing maturity of its unmanned platforms, but also the expanding capabilities of smart munitions. Tolen is designed as a standoff munition, meaning it can be released from a safe distance without having to approach the target directly. With a modern INS and GPS-based navigation system, Tolen is capable of achieving a high level of accuracy, minimizing the risk of off-target damage. One of Tolen's key advantages is its ability to maintain accuracy in a variety of terrain and environmental conditions. Its navigation system is designed to remain functional even in the face of signal interference, increasing reliability in complex operational scenarios. This demonstrates the increasingly important application of anti-jamming technology in modern conflict. The successful integration and testing of Tolen on the Bayraktar AKINCI represents a significant step in Turkey's long-term goal of defense self-sufficiency. Over the past decade, Turkey has invested heavily in developing a fully indigenous systems chain, from the airframe and avionics to sensors, data links, and precision weapons. This latest test confirms that the AKINCI can effectively carry, release, and guide Tolen munitions to their intended targets, validating the aircraft's advanced payload management system and munitions, guidance, and control features. The Bayraktar AKINCI is widely considered one of the most capable UCAVs currently in service. Designed for high-altitude, long-endurance missions, it ranks above previous tactical drones, bridging the gap between traditional UAVs and manned combat aircraft. Key characteristics of the AKINCI include high payload capacity, enabling it to carry a wide range of munitions and sensors simultaneously. Advanced avionics and mission computers support complex multi-role operations. Extended endurance and high operational altitude enable sustained surveillance and strike missions. These features make the AKINCI not only a strike platform but also a strategic asset, capable of performing intelligence, surveillance, and reconnaissance, electronic support, and precision engagement roles. Tolen is a domestically developed precision-guided munition designed to engage fixed and semi-fixed targets with high accuracy. This munition is typically guided using an INS/GNSS-based navigation system, enabling it to strike targets precisely even in challenging operational environments. Key attributes of the Tolen include high-precision guidance, reducing collateral damage. Modular design allows integration across multiple platforms. Long-range capability allows the launch platform to remain at a safer distance. Compatibility with both unmanned and manned aircraft enhances operational flexibility. The latest variant tested with the AKINCI incorporates enhancements aimed at improving accuracy, reliability, and mission adaptability, ensuring it remains effective against modern battlefield requirements. During the test, the Bayraktar AKINCI successfully carried a Tolen munition, executed the release sequence, and guided the weapon to its intended target. This type of testing is crucial because it validates not only the munition itself, but also the entire attack chain, including mission planning and target data transfer, aircraft munition, communication, release dynamics, and flight stability, guidance, performance, and terminal accuracy. The success of this test demonstrates that the AKINCI system can fully utilize the Tolen's capabilities, enabling operators to plan and execute precision strikes with confidence. The successful Tolen test on the AKINCI significantly expands the operational reach of UCAV. With each new domestically produced munition added to its arsenal, the AKINCI becomes more versatile and resilient in a variety of mission scenarios. For modern armed forces, especially those emphasizing unmanned systems, these advantages directly translate into increased effectiveness and strategic flexibility. The Tolen test also underscores the importance of systems thinking in modern defense development. Rather than viewing drones and munitions as separate products, Turkish defense companies are increasingly designing them as integrated components of a unified operational ecosystem. This approach allows for faster development cycles, smoother upgrades, and better overall performance. Improvements in guidance algorithms, data links, or sensors can be reflected across multiple platforms and weapons, creating a multiplier effect for capability growth. The successful demonstration of UCAV advanced munitions integration has implications beyond national use. The Bayraktar AKINCI has already attracted international interest, and the availability of a range of combat-proven domestically produced munitions further enhances its appeal in the global market. As testing and development continue, further refinements to the AKINCI and the Tolen munition are expected. Future efforts will likely focus on expanding mission profiles, increasing resilience to electronic interference, and enhancing coordination With other unmanned and manned assets, each successful test not only validates current capabilities but also lays the foundation for next-generation systems that will define the future of air combatant, which unmanned platforms play a central role. The successful testing of the latest Tolen munition on the Bayraktar AKINCI marks another significant milestone in Turkey's unmanned aviation and precision weapons programs. It demonstrates the effectiveness of indigenous design, the strength of platform munition integration, and the increasing sophistication of modern UCAV operations. As the AKINCI continues to expand its weapons portfolio, it reinforces its status as a highly capable and adaptable unmanned combat platform that reflects the broader transformation of air power. In the 21st century, Tolen's design allows integration with a variety of modern fighter aircraft platforms. Its aerodynamic structure helps extend the launch range, allowing the launch aircraft to remain outside the threat zone of enemy air defenses. This modular approach also facilitates the development of future variants or upgrades. Munitions are designed to interface with the avionics and mission management systems of the latest generation of fighter aircraft. This integration allows for more flexible mission planning, including dynamic target adjustments and enhanced situational awareness for operators. The development of modern military technology is characterized by the increasing use of precision-guided munitions. One prominent example of this innovation is Tolen, a long-range smart munition developed by the Turkish defense industry. The presence of Tolen demonstrates how advances in sensor technology, navigation, and aerodynamic design can significantly increase the effectiveness of airborne weapon systems. The presence of munitions like TOLUN provides strategic advantages to the user country. With long-range precision strike capabilities, operational effectiveness is increased while reducing risks to the launch platform. Furthermore, the development of Tolen also reflects the independence of the national defense industry in producing advanced technology. The sophistication of the Tolen ammunition demonstrates how technological innovation plays a significant role in the evolution of modern weapon systems. With its combination of high precision, resistance to interference, and adaptive design, the Tolen is a clear example of the transformation of conventional ammunition into a more effective and strategic, smart system in the modern defense era.